So today we are going to discuss about the relationship between elasticity and total revenue. Now we learned that as you change prices or if you increase prices, there is a decrease in quantity demanded and vice versa, which is called the law of demand. But obviously the sellers wants to earn profit. So what the problem is that when you raise the prices, your quantity demanded falls. So there's a good chance your profit margin might decrease because your total revenue is going to decrease. Now, depending on the elasticity of demand, it depends whether there's an increase in revenue or not as you raise prices. Let's try to understand this using an example. So this is the same example we did it in the previous lecture, but we are just expanding it a little bit. So the question is, or example is, in the fall of 2006, Pace University in New York raised its annual tuition from $24,751 to $29,454. As a result, what happened? Freshman enrollment declined from 1469 in the fall of 2005 to 1131 in the fall of 2006, where freshman enrollment is the quantity demanded. Obviously, if the tuition, which the price of education increases, your demand for education is supposed to decrease. First thing we are going to do, we'll calculate the price elasticity of demand. Then we'll try to find out if the elasticity is elastic or inelastic. Then we'll be doing some exercise with the total revenue, which actually the Pace University do care about. So first let's try to calculate the elasticity. So we all know elasticity of demand is percentage change in quantity demanded over percentage change in price, which is your tuition, and quantity demanded is your enrollment. First one, what is the percentage change in quantity demanded? So quantity demanded here changed from 1469 to 1131. So it will be 1131 minus 1469, and you divide it by the old number 1469 times 100. This is your percentage change in quantity demanded over percentage change in price, which will be 29454 minus 24751 over 24751 times 100. If you solve it, your top number would come out to be negative 0.23. The bottom number will come out to be 0.19. So your elasticity of demand is equal to negative 1.21. Now we all know we always drop the negative sign. So elasticity of demand is 1.21, which is more than 1. That means demand is elastic. So it's an elastic demand. Now let's try to understand what happens to revenue. So revenue in 2005, so total revenue in 2005. So revenue is nothing but price times quantity. Here in 2005, price was 24751. That's the tuition, times quantity was the freshman enrollment, which is 1469, which gives you $363,59219. So which comes to $36,359,219, whereas total revenue in 2006 would be $29,454 times 1131, which gives you $33,312,474. So we can see there's a drop in revenue from 36 million to 33 million when they increased the price. So did it help Pace? Obviously not. So what Pace failed to analyze is that how much is the responsiveness of the demand for Pace education as there is prices. So today we are going to focus on the relationship. So here I have given you two cases. So this is an inelastic demand curve. On the left one, panel A, this is an inelastic demand curve. Why this is inelastic? Because it is steeper. And this is an elastic demand curve, which is more flatter. So B is an elastic demand curve. When the price says $5, at $5, quantity demanded is 90. When price drops to $4, quantity demand increases to 100. What happens to total revenue in this case? At $5, revenue is 5 times 90, which is $450. At price $4, in this case, revenue is 4 times 100, which is $400. What we see here in the case of inelastic demand, actually as price decreased, your revenue decreased. So price decreased, which means total revenue decreased. This is the case of inelastic demand. On the other hand, in the case of elastic demand, you may say at $5, this is 5 times 70, which is $350. At $4, because this is elastic, is 4 times 100, which is $400. So what we see here is there's an increase in revenue for the elastic case. So price decrease leads to total revenue increase in case of elastic demand. So this is a very important relationship. So what we are saying here is that price and revenue move in the same direction for inelastic demand. Price and revenue moves in the opposite direction for the elastic demand. So try to put all these things in a context. So when the demand is inelastic, which means price and total revenue moves in the same direction, which means as price decreases, total revenue decreases. On the other hand, as price increases, total revenue increases. When the demand is elastic, which means elasticity is greater than 1, we have price and total revenue move in the opposite direction, which means as price increases, total revenue decreases. On the other hand, as price decreases, total revenue increases. This was the case of the Pace University, where it was elastic demand and they raised the price. What happened? Their total revenue decreased. And finally, it's a very special case where elasticity is equal to 1, which means perfectly elastic. Total revenue remains constant if there's a change in price. So always remember, before you raise the price of the product you are selling, make sure you understand what kind of demand you are facing. That's why in a very competitive market where the demand is very elastic, sellers don't want to raise prices. Rather, they try to reduce prices so that they can help with the total revenue. On the other hand, in a less competitive market where demand is not very elastic, that means people really don't have a lot of choices, sellers can increase prices. As a result, they can increase revenue and profit.